We are going to use Desmos to write linear equations. So you're going to put this divider, Desmos divider, in the very back. So remember, in the very back, we have the back pocket, we have the unit test chart, and then we have two other Desmos activities. You're going to put that in the back. We're going to follow the instructions. So I need you to follow the instructions with me. You should be doing the exact same thing at the exact same time as me, so that you can answer questions or get your questions answered if you're not sure how to do this. So step 1 says click the plus. So everybody on Desmos, click the plus. And that means you're going to add an item. Step 2 says add a table. Okay, so here's our table. And then you're going to input the values for X and Y. So these are the values that we're going to use for X and Y. Let me focus that. So you can go straight down the X side, or you can go back and forth between X and Y. I don't have a 5, so I'm going to back it up. And then put in the Y. And as you plot them or put them into the table, it actually plots the points on the grid or on the graph. I want y'all to do something for me real quick. Click on the graph settings, and I want you to take off the minor grid lines and put your step as 1 on both of them. So I took off minor grid lines, did our step as 1 for both, and then hit the settings button again. You can turn back on the minor grid lines if you want. Either way. But that's how you can make sure that you can see all the points really good. All right, let's go back to our instructions. Step 3, in the next line, type y1 and then this little squiggly, ilm x1 plus b. So in line 2, type in y1. Whenever you put the 1, it takes it down to a subscript. Then look for the squiggly. Mine is above the tab, but I have to do a shift. M x1 plus b. Whenever you do that, it gives you this information. So step 4 says round the m and the b to 2 decimal places and write the equation as y equals mx plus b. So let's go to the back side. We're going to write the equation. So what we have over here should be the exact same. So it says r squared 0.981, r is 0.9904, m is 0.95, b is 12. So our equation is going to be written as y equals mx plus b. And we have under parameters the m and the b. They've given us the m and the b. So we can write our equation y equals 0.95x plus b plus 12. So that's the equation for the line of best fit. See how this line goes pretty close through the scatter plot? So if I go, well, it already graphs it. See how if you take it off or click it on, it gives you that line of best fit. Okay. Correlation coefficient is R. So we are going to write what that is. R equals 0.9904. And in our lesson today, I'm going to tell you what R means. R is a correlation coefficient. It tells us a little bit about the scatter plot. All right, let's get out the notes for today. Leave your journal out so you can refer back to it for the steps if you need them. So let's go ahead and look at our notes. Don't glue this in just yet. Just let's go through it. It says linear regression in Desmos. These are the same steps. Click the plus. Step 2, add the table. Input X and Y. Step 3, in the next line, type Y equals or Y1 squiggly MX1 plus B. Step 4, round M and B to 2 decimal places and write the linear equation Y equals MX plus B with M and B. Optional is your correlation coefficient. So it's R, not R squared. In Algebra 1, we are not going to look at R squared. So only look at R. So let me tell you about what R is. R shows the strength and direction of correlation. The only values for R are between -1 here and +1. You can't have an R value that's bigger than 1 or smaller than -1. It's all between. So correlation coefficient is R, is between -1 and 1. So look at 0. If your R value is 0, then it is a zero correlation, a no correlation. It's like a scatter plot that's all over the place. Strong positive, see how positive is anytime your R is plus, it's a positive number. Strong means it's close to 1. But it can be a strong negative. Negative is close, or strong negative is close to -1. And weak is close to 0. And then if it's a perfect linear correlation, it's a 1 or -1. It's exactly 1 or -1. It's not like 0.9904 like our example was. It's exactly 1, and it will be a line. It means that you can plot points to get a line. Okay, I want to look at something with y'all real quick on Desmos. I want to look at an assignment or notes that we did last week. So this is the one that says point slope formula. So that's how we wrote an equation from 2 points. But I'm going to teach you the trick that will give you the same equation. Yes, ma'am? So this problem, it gave us 2 points, and we were asked to find the equation slope-intercept form. Well, the great thing is I have a way to go around this, okay? It's using Desmos. So let's go to Desmos, and let's clear out what we have, and let's follow the steps. But for this, we are going to do the points in a table like that. So if you look back at the notes from the other day, the point slope notes, okay, we are going to click plus, go to table, and we are going to put this in 0, -2, and then 3, 4. And see how it plotted the points for us? Here's a point, and here's a point. We're going to do the linear regression. So everybody type this into number 2. It's the Y1 squiggly MX1 plus B. So look how it gives us the M and the B. Look at this equation and look at what they've given us here. Y equals 2x minus 2. Same thing. So from now on, you don't have to use point slope unless it's asking what is point slope. You can use this linear regression shortcut. Okay. All right. Let's go to the problem now, the examples that we have on here. Example 1. A convenience store manager knows that sales of soft drinks are higher on hotter days, so he assembles the data in the table. We have high temperature and number of cans. So we're going to call high temperature as our X. Number of cans as our Y. A says use Desmos to make a scatter plot of the data. Let's clear out what we have. Let's go to plus, table. Let's put in the data. Put in all the X values, double check them once you finish, and then put in the Y values. $55, $58, $64, $68, $70, $75, $80, and $84. Then put in your Y values. $340. Oh, I messed up, didn't I? $340. Let's try that again. $335, $410, $460, $450, $610, $735, $780. Oh, I'm going to back it up so that I don't have like a like. And it creates a scatter plot, but I can't even see it. So I'm going to back it up. Oh, there it is. So if we look at it, it is a positive correlation, right? It's going upward. As the X values increase, the Y values increase. So that's a positive correlation. But we're going to look at our R value to see what that is. So go to line 2, Y1, squiggly, MX1 plus B. So we need to write our equation. So part B, find the linear regression equation that models the data, round to 2 decimal places. I'm going to write my M here and then my B. So I want 2 decimal places. So 16.416, because there's a 6 in that third spot, it's going to be 42. And then B to 2 decimal places, the negative 621.83. Write your M and your B. And write your equation. Y equals 16.42x minus 621.83. Is that what y'all got? Okay, just making sure. Okay, and then, so that's our equation, mx plus b. And then it says, what's the correlation coefficient? So that's the R value, not R squared. Do not use R squared. We're going to round this to 4 decimal places, just like it shows up. 0.9673. And then what does that mean about the data? So look back at the front. Is it positive? Is it negative? Is it strong or is it weak? So what is it close? Close to +1. So it's strong and it's on the positive side. So we're going to write strong positive correlation. And the last question says, use the model to predict soft drink sales if the temperature is 95. So our temperature is the X value. So this is the model. We're going to use this model to predict for 95. So this is kind of like an F of 95. Remember F of X? I'm plugging in 95 for X in this equation, F of X. So let's put what we're going to put in the calculator or in the Desmos. So F of 95 means X is 95. We're substituting in 95 for X. I'm just going to put it straight into number 3. So I'm going to do 16.42 parentheses 95 minus 621.83. And then look what pops out, 938.07. So use the model to predict soft drink sales at 95 degrees Fahrenheit. So that equals 938.07. And we're talking about soft drink sales. Soft drink sales. So whenever it's 95 degrees outside, it's predicted that they're going to sell 938 soft drinks. That's what that means. All right, so go ahead and do example 2, and then we're going to look at it. So let's see. I've already put it in mine. And something I did was with this graph. So I want y'all to go to, because it's hard to see the way that you have it, the way it's just defaulted. So everybody go to this little wrench. That's the settings. We're going to change our x-axis to represent the x value. So look at your x values. It's your domain. So remember domain? It's all your x values. So look at your x values. They go from 0 to 4. So what you can do on your axis, go to 0 to 4. In our step, it would be about ones. Then our y's is our range. So look at your y values. What is the smallest y here? 826. So I would just go a little bit below that. Let's do 800, just so we get an idea of what this looks like. And then what's the highest? 954. So you can change that to 1,000. This way you're given a better picture of what the scatter plot looks like. And then you can click off major, minor. You can keep them on. You can play with it. Okay. So look, and you can kind of scoot it around. Look at your graph. What kind of scatter plot is this? It's going down, so it's a negative correlation. Is it pretty close to the line? Pretty much, yeah. It's not too bad. And again, that was under the wrench, and you just change your x values to match what your x values are here. Just maybe a little bit more, a little bit less, then you can play with it. And then y values, you want to mess with the y's, so that's where you put that here. Okay, so then our equation is going to be on B. Our m value is negative 36.9. That's a slope. Remember, negative slope means it's going downhill. Negative 36.9. And then our B is 961.2. So you're going to write those down. Then write your equation. mx plus b And then write your correlation coefficient. That's the R value. So R equals negative 0.9495. See how the R squared doesn't even say negative? It's because it's squared, and you can't have a negative squared. But we want to look at only the R. It's a negative, so that means it is since it's close to -1, it is a strong negative correlation. Make sure you write those words down. And that came from the front of this foldable. Then the last question says, use a model to predict the number of new cases for year 2019. Am I going to plug in 2019 for X? Let's look back up here. It says year since 2010. Look at that. What am I actually going to plug in? I'm actually going to plug in 9 because this represents 2019. Because this would be 0 years since 2010. So this is 2010. So 1 year would be 2011. Make sure you write these out to the side. 2 years since 2010 would be 2012. 3 years, 2013. And 4 years, 2014. It's just to simplify the table. All right, so then for 2019, what are we going to plug in? 9. So it's going to be f of 9. We're plugging in a 9. So negative. Oh, did I forget my x here? Oops. I forgot my x. Don't forget your x there. X plus b. I forgot my x. Negative 36.9 times 9 plus 9, 61.2. Go ahead and put that in. Put that into Desmos. Negative 36.9 times 9 plus 9, 61.2. Did I do it right? Will y'all check and make sure you got the same thing as I did? So 629.1? Is that right? Okay. And it's talking about new cases, right? The newly reported, the number of newly reported crime cases in the county of New York since 2010. All right. So you have an assignment on Delta Math.